Hey Golden Ones, it is I, the Kobold. One of the most powerful tools you have available to you when trying to make your game look good is shaders. There are two types of shaders that you can use. Vertex shading is done before your polys are rasterized, and pixel shaders are done before draws are blended. Since we are focusing on 2D, we will focus on pixel shaders. Let's go over the basics of them. MonoGame uses high-level shader language, or HLSL, to program its shaders and uses .fx files to store them. The MGCB editor will compile them for you, and you can use the content pipeline to load any shader you want as an effect object. FX files created by the MGCB editor looks like this by default. The main thing you need to remember from these default files is these definition lines. This tells the compiler which version to compile it at based on your graphics target. The default includes a vertex shader, but since it isn't as useful to our purposes, we can just remove it completely. At the end of the FX file, you will see this portion. This defines a technique. You need at least one per shader, but you can have multiple. Inside the technique is a number of passes, though you'll usually just use one. A pass is what will change the texture you are drawing. Each one is additively blended together before being blended to what you are drawing it to. This line tells it what function to run for the pass. Here's our function that will do our pixel shading. This float4 means it will return a vector of 4 floats, which stands for red, green, blue, and alpha, with values between 0 and 1. This function is run over all the pixels of the drawn texture before drawing it. The parameter that it receives can be a number of options, but MonoGame's default structure is an okay thing to use. Finally is this colon and color tag. The pixel shader needs both float4 and color to show that it is a pixel shader. Let's look at the input structure to explain it a little more. The default input structure is called vertex shader output. Since the pixel shader is done after any existing vertex shader, it takes its input from the other's output. By default, it only includes 2 values. The first is a float4 position. This isn't very useful if we are only using Spritebatch. You can remove it as we won't be using it. The second is a float4 color. Color isn't the color of the point on the texture you are drawing, but the color passed by the quad used by Spritebatch. So most of the time, it is probably white. The default shader just draws the whole rectangle this color. There is a useful value you might want to add, and it's this float2 texture coordinate. This tells you where on the source texture you are drawing. If we only had access to our source texture, we might actually be able to do some cool things. Thankfully, we can create a new variable of the sampler 2D type. This will hold the texture passed by the Spritebatch, and now we can use the colors from that to do some cool stuff. Let's go back to that main PS function. Alright, let's define a float4 to hold the original color of this pixel. We do this by the text2D function, which takes a sampler and a float2 of coordinates. It gets the color from the sampler at the coordinates. So we pass our sampler and the texture coordinates from the input. Now we have our pixel's color. I want to turn it into grayscale. To do that, I need the average of the red, green, and blue values of our color and return them. So, a cool thing about HLSL is we can get each float value from a float4 by using .r, g, b, or a. So we add our r, g, and b values, and then divide that by 3. Now we got the float that is an average of all 3 values. Since Spritebatch tints the sprite using a color, we want to do that by multiplying the color passed by Spritebatch, which will be in our input parameter, by the average. The other cool thing is we can get a float 3 by just using .rgb, which will be the red, green, blue values. So we take that RGB vector from the color passed by Spritebatch and multiply it by our average. Finally, we need to return a float 4, so we construct a new one using that new RGB value and adding on the alpha from the texture. Bam! We got us a cool shader that will grayscale our texture we are drawing so that tinting works better. Make sure your effect file is in your MGCB file. To use this effect with MonoGame, just create a field to hold your effect, load it in load content, then reference it in your Spritebatch.begin method. You should get some output like this. Wow, we learned the very basics of pixel shaders using MonoGame. There's a lot you can do with these bad boys, and I know that there will be more videos down the line going over more techniques. In fact, next week, we are going to turn this grayscale filter into a way to swap colors on your sprites. If you like what you're seeing, please remember to subscribe and leave a like. And as always, stay gold, code bold, and farewell from the Code Bold.